Hello, hello. We are continuing factoring. We're at the end of our polynomial chapter, and we're just about ready to get into quadratics and graphing something that's not a line or a V or a step. But before we do that, we have one more type of factoring to go over. It is called factoring completely, and this is extension 7.9. I have heard, now when we talk about factor completely, when you factor a polynomial completely, you are writing it as a product of prime factors. But I've also seen it factor completely as like a double factoring problem, like you have to factor each polynomial twice. And there's also another part of factoring completely, which is factor by grouping. So when you factor something completely, generally it's double factoring or factor by grouping. It can all be lumped together. So here we go. Let's go by factor by grouping. Now, when you factor by grouping, it's very obvious because when you factor by grouping, you have four terms. And what you do is you put them into groups. So example 1 is going to be factor by grouping. Okay, so you've learned how to factor by GCMF. You've learned the ninja star, when A was 1 and when A was greater than 1. And now you're going to learn how to factor by grouping. Factor by grouping, there's four terms. And if you group something, you are using your grouping symbols, also known as your parentheses. Here we go. Let's go x to the third plus 3x squared plus 2x plus 6. I don't have any ears on. Do I stop? Oh well. Oh well. No ears today. All right. Here we go. We're going to factor this by grouping, which means we are going to put this polynomial, which happens to be a four-term polynomial, no specific name. Kids of the past have always called it like a quadnomial. Sounds good to me. We're going to make this into two groups. And before you do anything, you want to check to make sure this guy's in standard form. So highest term on the left, down to the lowest term on the right. And this one is in standard form. After that, you are going to then make groups. You can make two groups. So you're going to put the first two terms into a group and the second two terms into a group. Now, when you group, it's really important to include the signs for the second group over here. And then you factor this group. So you're going to factor by GCMF. So x cubed and 3x squared, the most you could pull out is an x squared. And then you can say it's a couple different ways. X cubed divided by x squared is this guy. Or you can say it's multiplication. X squared times this will get you this. Which no matter how you say it, you still get an x. And then 3x squared divided by x squared is just a 3. And if you want to double check to make sure you factor that correctly, multiply this out. X squared times x is x cubed. So far, so good. X squared times positive 3 is 3x squared. And you want to do the same thing over here. So you're going to factor by GCMF. So the greatest common factor you can take out of 2x and 6 is a 2. And tell me what's left here. So 2 times something gets me 2x. X. 2 times something gets me 6. Plus 3. Hopefully you caught on that these are the same binomials. And that is the whole point of factoring by grouping. So when you factor this by grouping, you are trying to get the same binomial. You want to think of it as kind of like a common denominator. What is the common denominator within both of these groups? Which is x plus 3. Now we're almost done. To get the answer, you're going to put your GCMFs together as one binomial. And then as your other binomial, you're going to use the one they share in common, which is x plus 3. You do not write it twice. That's why I was saying it's kind of like a common denominator. So if you have 3/5 plus 2/5, you don't add the denominators there. Well, just kind of like here, you don't write both of these polynomials. You just write it once. So the one they share in common is the other one binomial. And you have just factored by grouping. How do you know if you got it right? FOIL it out. X squared times x, x cubed. X squared times 3, 3x squared. 2 times x, 2x. 2 times 3, 6. And what you'll notice, when you factor by grouping, you do not have an OI to combine. So there you go. There's factor by grouping. Let's do another one. Let's go x squared plus y plus x plus xy. This one's a little tricky. It's going to get you to think. Can't easily just set up our grouping symbols like this. And, like this problem I told you, you want to make sure it's in standard form. Well, how do you know if it's in standard form? Well, here's an x squared. There's power of 2, power of 1, power of 1, power of 2. I should not be saying power, I should be saying degree. Degree of 2, degree of 1, degree of 1, degree of 2. So you want to put this xy up here. Okay? Because they share something in common there. So when you get a polynomial like this where it's all just variables, when you don't have any coefficients, think about the degree and then order from your highest to your lowest. So I'm going to rewrite this as x squared plus xy plus y plus x. Now do your grouping symbols. Did they put that in order in the book? Yeah, they did. And actually, they grouped it a different way. I've always done it by a degree. You can group it another way. You can go x squared plus x plus y plus xy. You can group it that way. We're still going to get the same answer, though. All right, there we go. So, group the first two, group the last two. Factor this by GCMF. So we have x, and then we have x plus x times what gets me xy? Y. Okay? So now remember, our goal is to get this binomial, not this binomial, sorry, that binomial over here. That's got to be the common binomial. And x plus y. And I need to get x plus y out of y plus x. Well, remember that commutative property tells you you can add in any order and still have it be the same. So this is saying like 2 plus 5, and this is saying 5 plus 2. You still get the same answer. So technically, y plus x and x plus y are the same binomial. But you still have to factor it. So what can you take out of this? How about a 1? One times what gets you y? Y. 1 times what gets you x? X. And put your GCMFs together. So you have x plus 1 times quantity x plus y. Because remember, x plus y and y plus x, these are the same binomials. They're just written backwards. And that's your answer. If we would have rewritten this guy as x squared plus x plus yx, you would have factored out the x, and over here you would have factored out the y. You still would have gotten the same these guys, and you still would have gotten these guys the same as well. I've always just done it by the degree. Like here's a degree of 2, and that's a degree of 2 as well. Just going to show you there's more ways of doing it. I'm going to do one more of those. Toodaloo.
Toodaloo.
I think he forgets the toodaloo part. He gets the toodaloo part. Toodaloo.
That's Mr. Burns and The Simpsons. Toodaloo.
Oh, I don't watch The Simpsons.
I
He's
don't
telling
watch
me
The
it's
Simpsons either, but you see the commercials.
Oh, Simpsons reference. Toodaloo. I guess I have to
The
watch
kids
them.
would know, maybe.
Maybe you'll know. What's the Simpsons Simpsons character that says toodle-oo? I don't know. Learn something new every day. Okay, last one. X cubed minus 7 minus x squared plus 7x.
Come on,
Check to make sure it's in standard form. Highest degree over here, lowest degree there. It is not, so let's rewrite this. X cubed minus x squared. Don't forget your signs to the left. Super important. Plus 7x. And then a minus 7. You know, I often wonder, like, other YouTube videos, like, people who are trying to teach, like, do they have interruptions? Do they have, like, announcements, whatever? Do they stop and edit, or do they just keep going? I don't know. Kind of makes it more fun when we have interruptions of the kind. All right. Now that we're in standard form, let's group them up. Grouping symbols, also known as parentheses. Group the first two, group the last two. Pull out your greatest common monomial factor, which happens to be x squared from the first binomial. X squared times, gets me that guy. X, negative x squared divided by x squared. Or if you don't like it that way, x squared times what gets me negative x squared. Hopefully it came up with negative 1. When in doubt, multiply it out. Aha. There we go. All right, now the goal is to get this binomial over here. Same one. But let's GCMF first. So we can take out a 7. 7x divided by 7 is an x. Negative 7 divided by 7 is a negative 1. We got it. And our final answer includes these guys put together for one binomial. And the one they share in common is the other. We don't write that twice. There you have factor by grouping. It is under factor completely. But the good thing about factor by grouping, it's really obvious to tell because there's always 4 terms. That's all you can do with 4 terms is factor by grouping. So that's that. Okay, now the next part. Technically, our directions factor completely, which means double factor problem. And that's why I call factoring the F word. It's making a lot of noise. Factor completely. Through my years, I've seen these directions mean a lot of different things. I've seen grouping under completely. I've seen double factor problems under completely. And I've seen just regular factor problems under factor completely. I wish I had a super solid answer as to what exactly it means. But remember, when you factor something completely, you are writing that polynomial as a product of prime factors. Also, think of this as a double factor problem. And we got introduced to this last week. Here we go. 3x cubed minus 18x squared plus 24x. They don't give you many problems in here. Okay, let's factor completely. So the first time we factor this, it's always going to be by GCMF. So you're going to pull out what's common between each term within the polynomial. So let's go for coefficients. 3, 18, and 24. The highest coefficient that come out is 3. And let's check variables. How many x's can I pull out? Only 1. So 3x is our GCMF. All right. 3x times something here gets me 3x cubed. And that is x squared. If you are questioning it, make sure you multiply this out, which I do get that. Here comes the other way of saying it. Negative 18x squared divided by 3x, so negative 6x. If you don't like the way I say it in division, say 3x times negative 6x gets me negative 18x squared. And then 24x divided by 3x, also known as 3x times something here, gets me 24x. which that is, what is that? Plus 8. Okay, we factored once. Now we factor twice. We are going to factor what's in the parentheses. How do you factor x squared minus 6x plus 8? Ninja style. So remember, a times c at the top. A is 1, so it's only going to be 8. B at the bottom, ax and ax, so this time it's just going to be x and x here. Okay, sign patterns. C is positive, B is negative. So that tells you both factors are negative. So factors of 8, 1 and 8 and 2 and 4. Can any combination of signs of 1 and 8, oops, sorry, get me negative 6? Plus it can get to negative 7. I need negative 6. It's going to be 2 and 4. But remember, I just reminded you guys that both factors have to be negative. Okay? No simplifying here. This guy's got to come all the way down. So we have 3x times quantity x minus 2 times quantity x minus 4. Voila. You have just factored completely. Each one of these terms, nope, not a term, sorry, each one of these factors is a prime factor, so you know for a fact you've factored it completely, because you can't do anything else with it. But how do you know if you did it right? Multiply it out. You can multiply 3x times this, get that answer, then multiply that times x minus 4. Or you can FOIL these guys out, get that answer, and then multiply it by 3x, which will get you back up here. A couple different ways you can check it. But that's factored completely. Think of it as double factoring. And also, don't forget your GCMF. That is probably the most common mistake that kids make, is they'll forget to bring this guy down. Okay? Most of the time, I would actually write it here. I'll write it out. I'll write out in front of my Ninja Star just to remind me so I don't forget it. Okay, let's do another double factor problem. Because they don't all have to be trinomials. This is one we've kind of done before. Okay. 2 terms, and I have to factor this twice. GCMF is always first. All right, here we go. So greatest common binomial factor of 7 and 28 is 7. X to the 4th and x squared is x squared. What's left? X squared minus 4. How do I know? Then multiply it back out. That's our first time factoring. And so now I've got to factor whatever's in my grouping symbols. But there's only 2 terms there again. But double check, what are the 2 terms? You have your quadratic and your constant. And since you're missing your linear term, that tells you this is a difference of squares. So bringing this guy down. When I factor difference of squares, you can do Ninja Star, but I don't. I just tend to square root the first, square root the last. Set up your 2 binomials. Plus, minus, minus, plus. That part doesn't matter. You could put plus and then minus there. And then square root x squared, which is x and x. Square root 4, 2, and 2. And you're done. So if you see a 2-termed polynomial under factor completely, chances that is what I call a hidden difference of squares. Hidden DOS. Because you have to factor it twice. And the first time you factor is guaranteed a GCMF. Double factor. Double the fun. And then, sometimes they give you something like this, which I don't necessarily agree with. I don't agree with this. But you know what? I've seen it on tests. I used to see it on the old state test, believe it or not, for Common Core. P squared plus 4p minus 2. And that's supposed to be a double factor problem. Okay, so you're going to do what I tell you to do. Miss Parks said pull out a GCMF first. Well, the only factor that each one of these terms share in common is 1. So, I mean, I could do that. I could factor this. But did I get anywhere? I did not. So if they give you a problem like this, factors of -2 that add up to 4, no matter what you do with your signs, your factors of 2 and 1, you can never, ever get a positive 4. No matter what you do. You can't. So if they do something cruel like this, yes, you could factor it. But the thing is, you can't factor this guy. So this polynomial right here is prime. Meaning, you cannot factor it. It is already written as a product of prime factors. Here it is. That's a prime factor, and that's a prime factor. I don't like it when they throw those in. They try and trick you guys. I used to have my kids write not factorable, but I think Common Core, all that stuff, now they're preferring you guys to write prime. So there's that. Okay. So, factor completely. Really two types. Factor by grouping, which is 4 terms all the time. You never ever have to guess. So if you see a polynomial of 4 terms, just know I have to make these into 2 groups right here. Okay? But for some reason that always falls under completely. I don't know. And then factor completely, which means, you know, writing as a product of prime factors, also known as double factor problems. So it's like 2 problems in 1. Yay! Okay, kids. Have a great day. Happy Monday. Be excellent. Be kind. Toodle-oo, as Scott would say, and or that Simpsons character, which I really need to look into this. Bye now.